Check out the calcium aluminate cement, which has been overheated. It's sort of starting to crumble now. That's the crucible stand. Totally lost its integrity. So it pays not to overheat your mixture. Not sure what's going on down in there. The furnace is stable. It's not doing the same as that crucible. I think the air gets to it and turns it into powder. Yeah, lucky I got a spare one. Okay, what we have in this pot is 100 mils of urea mixed with this amount of water. I think it's a litre. And I've got the feathers soaking in there, as you can see. They're sucking up the urea and the water mix. I'll leave them soaking for a bit. I might put a bit more in there to suck up that extra moisture, but hopefully the urea and the water should be getting into all the feather structure, and we may be able to have something different. I'm going to cook this in 1 day on around about 800 degrees. The container should be right. Only these pieces which break off and fall in the carbon will be the metal bits. So if I don't touch it too much, it should be okay. So I'll get back later. Okay, this time I put some charcoal inside the crucible with the feathers mixed with the 100 grams of urea and water. Hopefully it cuts down on some of the fumes. I put the steam boiler chimney on, so that should also make the fumes go up there a bit. Alright, so I get about 5 hours I think. The gas bottle's 3/4 full. Okay, it's been cooking for 3 hours at superheat now. No smoke coming out the top, and the chimney temperature is 130 there. 119 up there, and in the hood 70, and we're a fair distance away. The torch head is glowing, and that's at high. We have to hold it about that distance away. So it's around 500 degrees in there. And the outer container, that's 160 there. The refractory is going to get damaged. I'm going to reline it with just the refractory cement and no sand. And the gas bottle's almost out. I think I'll make 4 or 4.5 hours at that temperature. Still, it's about there where the frozenness is. Oh, it's freezing up actually. Alright, I'll be back. Okay, it's the next day. The furnace sort of seemed to hold up, considering the amount of temperature what went in there. But another couple of days it might penetrate more and flake off some more. And I haven't opened it yet. I packed that charcoal, what I bought from the shop ages ago when it was a charcoal furnace. So I'll pull the stuff apart and see what we got. Hopefully there's some feather carbon still in there. Okay, the first look in the container. That stuff there, if you can just see it, the flaky stuff, that would probably be amazing type of carbon formed on that, because the metal would act as a catalyst. So I'll try to collect some of that if it doesn't all blow away. I've got a lot of it formed on the side. I'll try not to disturb that and mix that with the other stuff, trying to get the charcoal out. The charcoal seems to have shrunk, or the feathers have, and for an ohms reading on the charcoal, that should be actually increased. Where is it? Here we are. Actually, that's quite good for charcoal. That was a piece of homemade stuff, 1.5, and shop bought one. This is a piece of the shop bought one. It seems to be different colour when it went in. It's more grey. Oh, and that's very impressive as well. Not sure if that would be all the way through that block though. It's quite thick. So I'll fish the rest of that charcoal out and we'll see what we got for the feather carbon down at the bottom. Hard to see now, it sucks the light out of it. Okay, superheating the feather carbon is a very bad idea. There is nothing, hardly anything left at sea like this. So extremely shiny, very light. I think most of the feather carbon's splattered on the outside of the charcoal or something. So just checking this little piece for conductivity. That's almost silver in colour. If I get the probes on. So it's actually higher than the charcoal, or I can't press much weight. Because the charcoal is 1.3, 4, 2, 1. So the charcoal's absorbed all the urea, I'd say, and everything else. Both forms, that's the homemade wood charcoal, and this is an unknown, whatever the redhead barbecue charcoals was, which it was never that conductive. So don't superheat your feather carbon because you can't really see in there. It totally sucks the light. There's a little bit in there, not as much as I put in there. I think it's all vaporized. I think I'll get another piece. Oh, dropped it. That's a good little piece. I'll take it inside and we'll get better lighting, I think. Reflecting from the sun and stuff. Alright, won't be too long. Okay, we're up to the fun bit, checking out the carbon. So the feather carbon in a metal container. This is a piece of it here. I'd imagine this is just, that was right at the bottom. It's totally silver. We've got our little viewing lens. It's got a tinge of blue in some areas. Alright, so this here is most likely contaminated with metal particles because it's actually sticking to the magnet, where the other pieces we had from the previous experiment never actually, the big chunks weren't sticking. And this plate's quite thicker compared to that tub, and they're moving around a lot better. So we could have some sort of metal particles embedded into this, or maybe due to the heat it was a lot hotter, which changed its properties, but they're all sticking. And for conductivity in this stuff, see if I can actually get the probe on. Okay, it's quite hard actually. I'll just sit that there. Alright, I'll try this little piece right next to the gauge or the meter. Alright, we're high on conductivity, sort of, but it might be due to the pressure. I can't quite press too hard. So we're about 3.4, say. Try another piece. Still going up to the 3s, slightly under there. We're a little bit better there. So it's still probably worth using the stuff. It doesn't really matter because it's always going to come out of the metal container with the same properties. There's a bit of a darker coloured piece right there. Got the probe on that. Oh. Okay, that solid piece is much better. 1.6 on the ohms on that one, so we'll break it in half and see if it is carbon. Actually, it could be... No, it is carbon-ish. Still sort of unknown. And for the shop bought one, I broke a piece in half to see if it actually got in through the center of the because it's quite conductive out here. This shop bought carbon wasn't that conductive in the first place. So that's right, that's sitting at 2, dropping down. If I press the probes, 1.3, and on the inside here, if it's penetrated, it was hot enough to get probably through this stuff. Or actually not too bad. That was just shop bought. And for a magnet test on this stuff, oh, the magnet's sticking to everything. It won't hold its weight. So that doesn't seem to be attracted to it. So get rid of that bit. And for the homemade, the wood, this has been in the furnace a couple of times actually as just a smoke collector. It wasn't that high on conductivity the last time either, it was up near the 5. So we'll see what it turns out now with a bit of urea and water in it. Which is probably not too bad actually, for just wood carbon. So maybe a mixture of the wood carbon and there's some feathery, whatever this substance totally is. Might be a good blend. So the metal container did somewhat have a difference on the effect of the feather carbon. As to its true purpose of what it's doing, I'm not really sure. But I had a lot of carbon in there, a lot of feathers, and it sort of just turned into this stuff. There's a bit of flaky stuff from the side wall what fell in, but you can't pick it up, it just breaks apart. There, a little bit of extra bonus material. I guess if you use the same cylinder all the time, it's going to have the same properties. And I don't think the batteries really care, really. As long as the surface area is up and there's no side effects to the cell in its life. But that is totally shiny. Looks like a piece of metal to me. But this is strange how this one's not so conductive as this stuff. So I got a lot of this stuff. It's got the shiny stuff on the outside. There's probably graphene or something growing around there. I'm wondering if I could actually scrape the layer off and see what we get. So resistance over that area, just on that block of carbon, not too bad. The probes are a fair distance apart. This will probably make a good carbon. It's cheap, easy to make, you get bulk. Compared to that feather stuff, that's a bit more, well, I guess feathers are quite light. But when I get a microwave, I'll try that in the microwave as well. I've still got a bag and a half of feathers left anyway. And the other day when I did the zinc test, the camera went flat, so I lost the results. But for 2.5 hours, I only ran for 50 minutes, so the cell's a bit down. Sort of been sitting here since yesterday without any one discharge. And for a short circuit, 49 milliamps still, so it might be alright today, the cell. But the copper contact down inside's been sort of contaminated with electrolytes going up the side of the plate, and it's submerged in zinc sulfate. Well, that's still not too bad for a short circuit on the cell. Yeah, so there you go. A different version of the feather carbon with different properties. Oh, I nearly forgot. This was the stuff around that cap. It's most likely the wonder material, or what I call the wonder material. Could be graphene embedded with metal particles. Yeah, I'll check that conductivity if I can. I think it will break apart and The probes would most likely hit the bottom of the container, but we'll try. Nah, it's gonna punch through. Yeah, no, I can't get enough pressure on that. That's really flaky. So that stuff in itself is quite interesting. I know they use certain metals to grow their graphene and stuff on it. So that would probably be no different to something like that. Oh, check the magnetic. Yeah, see, that one's way, everything in there, that's actually, the container's stainless, so the magnet's not sticking to that, but with a slight bit of that, look at the holding power. That's not a lot of material there to hold that magnet. When I put that there with no material, then stick that up there. So that stuff's very attracted to a magnet. It's got like really good pulling force for it's lightweight. So the properties in that are quite amazing. And most of the oxidized metals, oh hang on, I think they do, they just don't conduct. Yeah. So there you go, something interesting, and we're still on a short circuit and it's down to 36 milliamps. Not a bad result, the carbon burn. It was only 4.5 hours and around about $5 worth of gas to make that lot of stuff. So that was quite cheap because I have a whole bucket of stuff which measures 1 ohm, 1.5 ohms. I have some wood stuff which is also conductive, which is better than the feather carbon in conductivity. So I can use these to mix up a lot of cells with now. Oh, I'll try this wood stuff. Nothing in the wood. The wood's not contaminated with metal particles for some reason. Anyone want to have a guess at why that would be the case? So the metal container may not be contaminating our carbons. See, you'd think that would stick, wouldn't you? That's no heavier than that other piece over there. I'll find a lighter piece. Oh yeah, that maybe was a bit heavy because that piece is quite sticky. See? And that piece. Oh, not as strong. This stuff doesn't have as strong as pull as the flaky stuff. See? That stuff's amazing. It won't stick to that container. The crumbs are, look at the fault. I got it in the middle and it's drawing it with ease from that far down. And it's attached itself quite well. So very strange results in here. Doesn't have a smell. I think these pieces, the silvery bits on the end of these, are quite interesting, perhaps worth scraping off and seeing what the results of that stuff is. Because any of that stuff could be actually real graphene growing. Well, carbon making is quite interesting because you never know what you're going to get out of the thing. I'll just break this piece in half and see what we got in the center. Really shiny. I'll check the conductivity. And we're about 1.7. That's pretty good over that area. It's over 25 millimeters there. 1.4, depends how hard you press. Oh, got down. 1.1, 1.2, and the meter, it goes to 0, I think, this one. So it's reasonably, depends how accurate this little cheapy thing was. So very interesting. So I can't wait to crush up some of this and turn it into some battery cells and see what we get. Alright, so thanks for watching, and I'll keep in contact.